move on to methane emissions. I'm glad I chose the order in the way how the survey came out. So this is a map that was generated by GHGSat. This is a satellite image that shows the methane emissions across the globe. And you can see two things here. Yes, there is a higher density here in the Asia region and China, which we kind of know. These are obviously the, call it developing or almost developed economies. And then it's interesting that the northern part has seen a little higher emissions, and also in China, the eastern part, more industrialized part of China, also has a bit more emissions, it seems. And also Southeast Asia as a whole also seems to be resulting in greater emissions. So this is the concentration that you can see here. And North America, this is the other thing, right? As a developed economy, will there be more stringent / dedicated efforts, if we may, in North America? So think about that as well. So with that said, why is this important? Why are people looking at methane emissions, right? So the key is methane has a global warming potential about 84 times that of carbon. So we talk about carbon that is coming out of the tailpipe from the automotive or any industry, but methane, which is an industrial product, and specifically oil and gas, in the production when they're extracting the oil and gas in the upstream from the fields, it results in a lot of emissions. It's getting better over time, but that is another source where a lot of emissions are released. So with that said, methane as a whole, as one element, a specific element, has about 84 times global warming potential than carbon. So the greenhouse gases, as they call it, methane is one of them, one of the highly potent compounds. Okay, that is why it's important. Now, with that said, how are people using methane data? When I was working at my previous employer, we have it's a $1.5 billion natural gas business that serves about about 10 lakh to 12 lakh customers. And then health and safety of our customers and health and safety of our communities is very important for us. So what we used to do, we actually take satellite images like this, geospatial images, either satellite, or we can have a specific drone looking for the methane frequency, for example, the thermal frequency. And when you look at the spectrum of various things, obviously methane has a specific frequency, right? So you would configure the drone and the camera for that frequency, and then you do a raster, as we call it, which essentially means you fly that drone looking for that specific signal, and then you take an image of that and then bring that back, and then we compare that over time. Why do we do that? Because we also want to do the same thing. We want to identify any possible leaks before it becomes a safety issue, before it becomes a hazard. That is one of the areas where people are using it. And that's why the first benefit is health and safety, same thing. And then protecting the environment. As I said, why do we need to be on the top of this? Because this is, to an extent, it is the responsibility of all of us to leave a better place for our next generations to live. That's also partly the reason why a lot of people are definitely getting behind this mission of making the planet cleaner, leaving a better place for the next generations behind us. And then also revenue protection. I talked about the possibility of identifying a leak. Imagine you are an oil and gas producer with million barrels a day, and that's usually how these businesses are. Okay, a million barrels a day. So what we can do, and there is some set of constant level of emissions that will be released, right? So you can track that. You can take that, and then you can trace the methane emissions over time. If the methane emissions is going up, there is probably a possibility of an equipment malfunction, for example. By identifying that, you are actually creating a planned outage, bring something down, as opposed to losing money on a forced outage, not knowing what is going to happen. So that's what people are using this for. Revenue protection. If you have a million barrels a day, you're using every possible intelligence that you can get, and methane is one of them, or any emissions, as a matter of fact, is one of them. Bringing all that together and then provide a reliability estimate. If that is going to lead into a forced outage, we can stop that. Again, operation excellence, doing more with less. That is the mission here. So I know I'm going to touch briefly on two things. One is Agritech and then the forestry. So Agritech, this is a very, very interesting field. We probably didn't hear about this much before. So in the last 10-15 years, there is a lot of progress and a lot of activity in various aspects. And in this case, one of the use cases is about use of optimizing the use of pesticides, I would call it. Use as much as you need. Now, organic is another one, right? Obviously, Landsdoctor partnered with some of the IoT-based devices where they are partnering, where they can understand the environment around you and use machine learning to bring the necessary protection for your crop. Think about it like that. So where are we using? Again, artificial intelligence to optimize the amount of pesticide so that the crop protection can be achieved, but also do that responsibly and sustainably. Okay, so that the production doesn't get compromised for the next crop or even for the later years. That is where a lot of focus is being put on. And then there are also IoT being used for soil conditions. And then not only that, trace and track the condition of the soil and everybody around you, because information is available, everybody around you, and what is the best way to provide the high yield with the best conditions known to that location. That is where geospatial AI comes in. So I even think of it as an ecosystem that is forming around this agriculture. There is robots that are helping the field in more industrialized nations. Whether you do it manually or not, there is a wealth of data that can be gained from the field, from the agriculture, from your asset, and then being used for various benefits, as we talked about. At the end of the day, how do we produce more with spending less? When I say spending less, not just the dollars, but also spending less of your human labor, so that you can use the human labor for something else, right? And that's the key. We'll talk about this. We need to have the mindset of, yes, some of these jobs are probably going to be replaced, but can we cross-train them? Can we look forward to have a different skill developed? But let me come back to this. So doing more with less is the theme that you see in every use case. Same thing with forestry, without going way too deep into it. How do we help the communities? Because obviously deforestation has to happen, but the key is sustainable deforestation. That is what the nations are working towards. And also sustainable farming, same thing, right? How do we leave a sustainable planet behind us? That is what excites the companies, that is what excites the nations. and everybody around it, whoever is in the industry, to take this forward from a, and then this requires various aspects of it, right? As you saw, a lot of data, synthesize the data, and then go from there. So with that said, for another question, let's go back to Slido, and this time, let me open up the second one. Okay, so go back again, slido.com 435876. Question now, what role interests you more in geospatial AI industry? Now that you have seen the potential, now that you saw how people are using it, right? What are your thoughts? What would you like to be? Would you like to be an employee in a geospatial firm? Would you like to be an entrepreneur starting up a geospatial firm, or would you rather manage teams in an established startup? What would you like to do? Nice, nice. I see a lot of entrepreneurial spirit. And I also see managing teams. I mean, again, managing teams is not necessarily a bad thing. That's more of an optimized decision. You know why? Because maybe there might be an established company out there that would like to get in deeper. I like it. And entrepreneurs, we need entrepreneurs, guys. So I want that to be high. So and again, everybody's have their own personal things, and then these things are as of today, right? So don't think of this as a decision that you're taking for a long time. That's not how we should think about it. This is about as of now, what excites you more in the industry. I think there can be a few more. We'll give it a few more seconds. All right. I like the responses. So there is a close tie between leading teams in geospatial firms and entrepreneurship. I like it. And that's great. I mean, that's really what I think we should be looking forward to in the industry. And we see the same thing. We see a lot of not only interest, but there is capital available that can be leveraged if you look at the recent terms. Okay, so with that said, I'm going to stop this. This is great. So there are a lot of interest on managing teams, which means, guys, this is great. When you're managing a team, you need to be broad, right? You need to understand how things work on a higher level. You're not going deeper into the weeds. It's good to know how things work, but when you're an entrepreneur or managing teams, the responsibility is pretty somewhat similar in terms of product development. Okay. However, the difference with entrepreneur, you take a lot more responsibility in funding, yada, 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 all that, right? Obviously, it's a lot more harder. But an established company, managing teams is a very good place to be. With that said, let's move on to the next part of the presentation. So now that we have seen how the industry is using, let's go a little deeper into what does it take to build one like this. We briefly touched on it. I want to actually take it as a process, right? As we said, in this case, I'm using drone as an example, but you can use satellite imagery, you can use the existing imagery sites like Google Maps, and even NASA is another source. And then I also think there is a similar satellite mapping service, EASA for Europe, EASA, just like NASA, but it's European Space Authority. And I also know even ISRO, our own ISRO, have that service. So think about this. We can submit a request and we can get imagery from ISRO as well, from the government, from the satellites that they used, and they will be able to share the data for a minimal amount. So that is the first step, right? No matter what you're doing, The first thing is acquiring that data, geospatial data, like we talked about. Once you do that, the next thing is data processing. You get enormous amounts of data. This is definitely a much bigger job in terms of processing the data, cleaning the data, and then 50% of the time usually is spent on this, guys. So think about this. The fun doesn't begin yet, but a lot of time is spent on processing the data, getting the data ready. We call it data engineering. Why? Because you have to prepare the data in such a way that it makes it easy for the data scientists to come in and do, I would call it the magic. But that magic would not even happen without a great foundation for the data. And billions of dollars are being spent on the data processing, data analysis, by the way. Once you have that, once you have a clean data, now you're starting to connect the dots. That is where most of the data science work comes in. And then here is where you're doing feature engineering, as they call it. What does it really mean? How is like we talked about, global warming is related to greenhouse gases. That's a connection, right? How do they do that? By using artificial intelligence, they actually trace and track the temperature, and then they also see the correlation, for example, with the greenhouse gas emissions, right? And then that is how they actually do that. So the algorithms are usually connected, are usually developed once the data acquisition and cleaning is done. This is the other key. It is a journey, right? This is not a one and done deal. This is not like a typical technology world where you install a server, you get a portal, and then we're done. No, it's not like that. It's a journey. You're on it. You're always improving. Continuous improvement is the key in a geospatial AI. You'll probably get, let me also be clear on the result. You might get 60%, 70% right. And that's okay. You know why? What is the alternative? 50-50. You can take a toss, right? Toss a coin, and then you heads or tail. That's 50-50. Anything better than that, it should be okay. Now, I'm not lowballing. That's not the point here. But the leadership usually should be prepared for that. So look for that signs when you're tracking and talking to someone. Their mindset has to be like this. What are the expectations? And if you're expecting 90% or 100% of the result, it might take some time. Are you patient? This is about a journey. This is, again, as I said, you can take sprints, but it is about taking sprints to a marathon. Think about it. A marathon is a 26-mile run. A sprint is usually what? Call it 3-mile sprint. So you take a 3-mile sprint, see what happens, take the next sprint. So think about it like that. Maybe even we call it Ironman, a 60-mile run, right? So that's the way how the process is usually built.